In the last video, we looked at an example of the quotient rule. I showed you how the formula works. In this video, we're actually going to prove the quotient rule formula. So let's open up a new page here. You can see I've already written down the formulas over here. So we're going to prove now that the derivative of this is actually all of this stuff over here. And the way that we're going to do that is we're going to first of all rewrite our original function f of x. So we're not changing anything. We are just representing it and representing the same thing in a different way. So we've got u of x times 1 over v of x. And what we're going to make use of in this case is the chain rule and also the product rule. So how does this work? Well, first of all, what I'm going to do is I'm going to rewrite my function, and I'm going to just substitute some other variable in this, just so it becomes a little bit nicer to look at. So I'm going to let a of x be equal to all of the stuff here. So I'm going to say let a of x equal to 1 over v of x. Okay, just for now. And so now you can see, well, as long as a of x is defined as 1 over v of x, this now becomes a problem that you can solve using the product rule. And so if you recall, the product rule is actually just defined as, well, that's u dash times my original function a plus u times a dash. So really the only trick to this problem is finding the derivative of a with respect to x. And for that, we can use the chain rule. So finding a dash of x, or dA dx, like that. Well, recall that using the chain rule, we can just do this. I mean, it already has a function of v in it, right? So we can just say dA dx is equal to dA dv times dv dx. So basically all we have to do now is find the derivative of a with respect to v, and then find the derivative of v with respect to x. Well, from here we can kind of take a little bit of a shortcut because we kind of know dv dx already, right? Because we know dv dx is just the derivative v dash of x, like that. And we can leave it like that, because right now all we really want is to have a symbolic kind of expression for our derivative. And finding dA dv, well, recall that a was equal to 1 over v. Well, 1 over v, we can rewrite that, right? So that becomes v to the power of -1. And now finding the derivative of this shouldn't be too bad, because we can now say dA dv is just equal to -v to the power -2. And, well, we can rewrite that again to make it look a little bit easier to look at. So this becomes -1 over v squared. And this should already look kind of familiar. You can see that we've got a v squared over here. Remember, v is still just our original function, v of x, right? So this is already, you can see, is our v of x squared over here. And now we can start to put these things together. We can find dA dx is equal to what? That's dA by dv, that was -1 over v squared, times dv dx, well, that's just v dash of x, like that. Okay, we can make that look a little bit nicer. That becomes -v dash of x all divided by v of x squared. Okay, and now we can start to put these things together. Now we can start to put these things into this form over here. So u dash times a, the derivative of my function of x, is equal to u dash of x times whatever a was. A was 1 over v of x times 1 over v of x plus u times the derivative of a, so u of x times the derivative of a, dA dx, which was times negative v dash of x over v of x squared. Now you might be thinking, well, this doesn't look anything like what we need, but it actually already is exactly the same thing. It's just not in the exact same form as we are used to. So let me just rewrite this a little bit. This becomes u dash of x over v of x. Now I'm going to take then everything's multiplied here by the negative v dash of x. So I'm just going to say, you know what? I'm just going to say this. Minus u of x times v dash of x, all divided by v of x squared. And so now you can see I haven't removed the negative. I've just said, well, all of this being multiplied by a negative, so the whole product here is just going to be negative. And then from here, well, it's a little bit closer to what we want, but still not quite. And so you just have to remember, well, how do I add and subtract fractions? Well, you just make sure that they're on the same denominator. So how do I get them on the same denominator? Well, they both have v of x in common. It's just I need to multiply this part here at the top and at the bottom by v of x. This becomes then u dash of x times v of x divided by v of x squared minus u of x times v dash of x, all divided by v of x squared. And now, for the final bit here, we can just say all of this stuff here is just equal to u dash of x times v of x minus u of x times v dash of x, all divided by v of x squared. And we're done. Now you can see that all of the stuff here is the same as the stuff here. And all you really needed was the product rule and the chain rule.